Dear students, today we will study about the uh, solution of system of linear equations. What is a linear equation? An equation which involves a variable containing highest power 1. For example, let us consider this equation. We see that the variables in these equations are x, y and z. A1, B1, C1, D1, these are constant numbers, just like 1, 2, 3, real numbers. These will be given to you, and we see that in this equation the power of variable x, y and z are 1. So this is a linear equation in 3 variables. That is the second equation in 3 variables, and that is the third equation in 3 variable x, y and z. So this is the system of 3 linear equations involving 3 variables. If there are 4 equations, so there will be 4 variables, and if there were 5 equations, so there will be 5 variables. So number of variables and number of equations in our case, it will be always equal to each other, directly proportional to each other. So we need to solve this system of equations. So let's see. First of all, we need to write this system in matrix form, which you have studied already in your FSC course, that how could we write this system of equations in matrix form. We write these constants in one matrix and these variables in a column matrix x, y, z, and this side is another column matrix d1, d2, d3. So this is the matrix form of these 3 equations. We denote the first matrix a1, b1, c1 and this whole matrix by a, because this matrix contains all the coefficients. These are the coefficients of variables, so that's why this matrix is called coefficient matrix. And this matrix contains only one column, so this is called a column matrix. And because x, y and z are unknowns, so this is unknown column matrix, and that is again a column matrix. That matrix will be denoted by a, that will be x, and that will be by small b or capital B, whatever you write here. So where a is called the coefficient matrix and x, b are column vectors. There are 2 ways to solve the system. To solve the system, we mean to find the values of x, y and z. To find the values of unknowns x, y and z, there are 2 ways. The first one is called direct methods, and the second one will be indirect methods or iterative methods. So what are direct methods? The first method in the direct methods is matrix inversion method, which you have studied in your FSC course. The second one is Cramer's rule, that will be known to you people. The third one is Gaussian elimination method. The fourth one is Gauss-Jordan method, and the fifth one is triangular decomposition method. So among these 5 methods, we will study these 3 and this one as well. And the last one will be studied actually in these methods, indirect methods. And indirect methods, the first one is Jacobi's method, which is very important, and the second one is Gauss-Seidel method. This is very, very important with respect to every examination point of view. So let us start from the beginning of these methods. The matrix inversion method. The matrix inversion method to solve the system of linear equations. The first step which is to be followed, we need to write the system in matrix form, Ax is equal to b. Secondly, we need to find the determinant of this coefficient matrix. determinant of this coefficient matrix. If determinant is 0, it means that the given matrix will be singular and the solution will not be possible there. If determinant of this coefficient matrix is 0, then we will say that the solution of the system is not possible. Secondly, if the determinant of this A is not 0, then we will say that the given matrix will be non-singular and the solution exists in that case, and then we will write this equation in this form, inverting A towards that side. So x is equal to A inverse B. This is actually small b, not capital B. So x is equal to A inverse B. In order to find x contains x, y and z. We need to find A inverse first, and to find A inverse, that is the formula for A inverse. A inverse equal to 1 by determinant of A into adjoint of A. Determinant of A from here, and we need to find adjoint of A by some methodology, by cofactor technique, and put the value of A inverse right here to get the value of x. So compare the corresponding elements. Whenever you put the value of A inverse in this equation and the value of B in this equation, multiplying these two and comparing the corresponding elements of the matrix to get the required solution. For example, if we are asked to solve the system of linear equations by inversion method, matrix inversion method, or simply inversion method, so that is the first equation. 7x1 plus 6x2 plus 3x3 is equal to 19. So we see here that instead of x, y and z, there are x1, x2 and x3. So it doesn't matter, we can write x1, x2, x3 as well. So that is the first equation, that is the second one, and that is the third one. So there are three equations along with three unknowns, x1, x2 and x3, and we need to use inversion method to solve this system. So first of all, we will write the system in matrix form. So this is the matrix form of these equations. Matrix form is 7, 3, 1 the first column, 6, 2, 4 the second column, 3 minus 1 plus 2 is the third column, and this vector will contain x1, x2 and x3, and that side is obviously 19, 7 and minus 2. So that is in the form Ax is equal to B. So what is the first step? The first step is to find the determinant of this coefficient matrix. So determinant of this matrix A is the determinant of these values. Expand by the first row. You can expand by any row or by any column, but try to learn the matrix, the determinant, to expand by the first row. How could we expand this determinant by first row? We will write the elements of first row 7, 6, 3 outside, 7, 6 and 3, along with alternate signs plus, minus, plus. Start from here, plus, minus and plus. And 7 will be multiplied by determinant, which is actually called, along with this sign, the cofactor of 7. So 7, exclude this 7, exclude that row which contains this 7 and that column which contains this 7. Excluding these two, 2 minus 1, 4, 2 is the cofactor of 7 along with this plus sign, and the cofactor of 6 is, by excluding 6, this row is contains 6, the row first, so this row will be excluded, and this column contains 6, so this column will be excluded. So we are left with 3 minus 1, 1 and 2. So that is 3 minus 1, 1 and 2. Then plus sign, plus 3. Now exclude this 3, exclude this row which contains 3 and this column which contains 3. So we are left with 3, 2, 1, 4. So 3, 2, 1, 4 is the cofactor of 3 along with this sign. Now how could we expand this determinant? That is very simple. 2 into 2, AD minus BC, just like that, this into that minus this into that. So plus 7 into 2 2s are 4, minus is in the formula, minus 4 into minus 1 is minus 4, then minus 6 into 3 2s are 6, minus 1 into minus 1 is minus 1, then plus 3, and that is 4 into 3 is 12, minus is in the formula, 1 into 2 is 2. Now simplifying this expression, we will get determinant of A 44. So this determinant of A, which is 44, that is not equal to 0. Determinant of A is not 0, so solution exists. We can find the solution of this system. So in order to find the solution of this system, we need we can write this system as by inverting this A towards that side. So x is equal to A inverse B. Now to find x, we need A inverse. And for A inverse, we need adjoint of A. How could we find adjoint of A? Listen carefully. How could we find adjoint of A? First of all, we will find cofactor matrix, and whenever cofactor matrix is obtained, we'll take the transpose of that matrix to get adjoint of A. So what is cofactor matrix? Cofactor matrix is that matrix which contains all the cofactors of these elements, the cofactors of all these elements. It means that 7 will be replaced by its own cofactor, 6 will be replaced by its own cofactor, and all these elements will be replaced by cofactors. So cofactor matrix is equal to, C is equal to, start from plus sign as I told you, and change this plus sign, plus minus plus, then this is plus sign, so that is minus plus minus, now that is minus sign, so this is plus minus plus. So these are the symbols, and now replace this 7 by its cofactor, exclude that row which contains 7, so this row will be excluded, and that column which contains 7, and we are left with 2 minus 1 4 2, so that is the cofactor of 7 along with this plus sign. So 7 is replaced, don't write 7 here, replace 7 by its cofactor. Now replace 6 by its own cofactor with negative sign, so 6 will be excluded, this row will be excluded, and that column will be excluded, so we are left with 3 minus 1 1 2, so that is the cofactor of 6, and this one is the cofactor of 3. So excluding this 3, this column will be excluded, this row will be excluded, and we are left with 3 2 1 4, that is the cofactor of 3. Similarly, this 3 will be replaced by its own cofactor, excluding this column which contains 3 and that row which contains 3, so we are left with 6 3 4 2 6 3 4 2 along with negative sign, this is the cofactor of 3. Similarly, excluding that row which contains 2 and that column which contains 2, we are left with 7 3 1 2, so 7 3 1 2, this is the cofactor of 2. And similarly, minus 1 will be excluded, minus 1 from here and there, so we are left with 7 6 1 4, that is the cofactor of minus 1. Similarly, 1 4 and 2 are replaced by their corresponding cofactors. Now simplifying this determinant, 2 2s are 4, as I told you before, 2 2s are 4, minus is in the formula, and by this minus that will be plus, 4 into 1 is 4. From here to 3 2s are 6, minus is in the formula, and along with this minus sign that will be a plus, 1 into 1 is 1. And similarly, all these determinants are expanded here. Simplifying, you'll get C is equal to this thing. So therefore, adjoint of A, which is actually the transpose of this C, will be just like this thing. This is C actually, and the transpose of this C will be obtained by interchanging corresponding rows and columns. It means that first row will be interchanged with first column, so 8 minus 7 10 will be in the first column, and 0 11 minus 22 will be in the second column, and third row will be in the third column. So this is the transpose of C. So that's how we find the adjoint of A, that we first find the cofactor matrix and then take the transpose of that matrix to get the adjoint of A. So that is the adjoint of A. Therefore A inverse is 1 by determinant of A into adjoint of A is equal to 1 by determinant, which is actually 44, so 1 by 44, and this is the adjoint of A. So that is A inverse. That is A inverse. Therefore X is equal to A inverse B. So this is the value of A inverse, this whole value, and this is actually B matrix, the column matrix. Now multiplying these two matrices, how could we multiply? First row with this first column, 8 into 19 plus is in the formula, 0 into 7, then plus is in the formula, so 12 minus 12 into minus 2, minus 12 into minus 2. Similarly, minus 7 into 19, second row first column, minus 7 into 19, 11 into 7, 16 into minus 2, and along with this row 10 22 minus 4 with this column, we'll get this thing. So adding these elements, we'll get X is equal to 1 by 44 into these things. More simplification will give you 1 by 44, 152 plus 24 is 176. Now multiply this 1 by 44 inside. So whenever you multiply this thing with that thing, 176 will be divided by 44. All these elements will be divided by 44, and we'll get 4 minus 2 and 1. So X is equal to 4 minus 2 and 1, but we know that X is actually x1 x2 x3, and this is equal to that thing. So comparing the corresponding elements, x1 is 4, x2 is minus 2, and x3 is 1. So these are the obtained values of x1 x2 and x3. So this is the solution of their system of equations by inversion method.